Okay, now looking at the National 5 2015 paper 2, going through answers to all the questions. So we've got question 1, we've got a house is valued at £240,000, its value is predicted to rise by 2.8% per annum, calculate its predicted value after 2 years. So if we think about the value of the house, to start with, it's worth 100% of its value. And then after that year, it's going to have added on that 2.8%. So if we look at that whole thing, that's 102.8%. So this question's compound interest, so we need to change that percentage into a decimal. So it's going to be 1.028. So the value after 2 years is going to be, we take the original price, which is £240,000, and we times that by the 1.028. And we need to raise that to the power of 2 because it is 2 years. If it was 3 years, it would be 3, 4, 4, etc. all the way up. And then we use our calculator. This is calculator paper, so we're fine. We just put that in straight as it is, and we get our answer, which is £253,628. So the marks here were for knowing that it was the 1.028 for this line and for your answer. Right, so question 2, we have a function, so we've got f of x is equal to 3x plus 2, and we've been told that f of a is 23, so we need to find what a is. So if we put a in for our x, we get f of a is equal to 3a plus 2. But we know that f of a over here is 23, so we can take that and replace the f of a here with it. So we're going to get 23 is equal to 3a plus 2. And that is where you get your first mark for knowing to substitute in and getting that. So from there we just need to solve. So we subtract 2 from both sides and we get 21 is equal to 3a. We divide by 3 on both sides and we get that 7 is equal to a. A is equal to 7. That's our answer. That's us done. Okay, so question 3, we have a triangle. We need to figure out what rule it's going to be. So it's not a right angle triangle, there's no right angles drawn on it, so we can't use Pythagoras or normal trigonometry. So that means it's going to have to be the sine rule or the cosine rule. We've been asked to find a length. There's no area mentioned, so it's definitely not that area of a triangle formula. So it's trying to figure out if we need the cosine rule or the sine rule, which is the difficult bit. So if we look, we've got the angle here, and we've got the two sides kind of by it, so they're all close together. So we've got this one here, that one there, and the angle in there. So those are all right next to each other, and if they're all kind of like that, all close together, that means it is the cosine rule. They're close, cosine. Both start with a C, can be a way to help you remember. So our cosine rule here, so we're finding a length, so our cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. Okay, so if we look at our triangle, we've got C, we have A, C is here, we have A here, and we have B here. So if we use this, C would go across here, so we'd have the little c here. But our formula's got an A, so we can just kind of ignore the things that we've got in our question and rename this one as A. So that means our side we want to find is our little a, so that helps us. B can stay as it is, we can put a little b over there, but this A, I'm going to re-letter as C to bring that C over there. So now we're trying to find that A, we know what B is, we know what C is, and we know what the angle A is, so we can get going. So we put in our B, so we have 1.2 squared, plus C, which is 1.35 squared. Then we're taking away 2 times B, which is the 1.2, times by the 1.35, all times by the cos of 35 degrees. So that can go into our calculator. We do that. We get that a squared is equal to 0.608, and then it keeps going. It's a recurring decimal. So to find a, we have to take the square root, and if we round it, we get 0.78. So here, because we've kind of named it, it's asked us for the length of AB. It's probably good to write that AB is equal to A, which is equal to 0.78. And not forgetting, because it's kilometres, it's 0.78 kilometres. And then the marks for this question come from correct substitution into the cosine rule, so that first bit, finding what AB squared is, or A squared is, and then for showing that you know that AB is 0.78. Okay, so we have a magnitude of a vector question. So we know that the magnitude of u is going to be equal to the square root of the x squared plus the y squared plus the z squared. So if we take our vector, that's our x, our y is our middle one, and our z is the end one. So we have the square root of 6 squared plus minus 13 squared. It's important to put this in brackets because minus 13 squared is not the same as subtracting 13 squared, plus 18 squared. So that can go straight into our calculators, or we can work it out first. So if we do it first, we get the square root of 529. So if you're not getting the right answer, that could be your mistake, is that you've not put the minus 13 in brackets, so you'll have got a mistake in there. You put the square root of 529 and you get the answer, which is 23. So the marks for this question are 1 for kind of starting the process, so putting the numbers in, and then 1 for your answer. Right, question 5, we've got vectors again. So if we're looking at our vectors, it's been asked in the question to express your answer in component form. So we need to write our vectors in component form, so we need to put them into that. So first things we need to do before we can add them is write them in our components. So we need to find out what values we go into our components. So if we look at our first one, so we always look in the x direction first, so the horizontal first. So if we look at P, we've gone 1, 2, 3, 4, 5 squares. And because we're going to the left, that's the negative direction, so we're going negative 5. So our first part is negative 5. Then we are looking at the y, so we've gone across to here, and we're going up 3. Up is the positive direction, so that means it's going to be plus 3. So P is minus 5, 3. Remembering that you're following the direction of the arrow. We look at Q. So we start at the start, the arrow is going that way, so this is the start of our vector. So we're looking in the x direction first, so we're going 1, 2, 3, 4. And because we're going to the right, that's the positive direction, so it's going to be 4. And then we are going from here, we're going down 1, 2, 3, 4, 5. Down is the negative direction, so it's going to be minus 5. Okay, and your first mark for this question is for having one of these correct. One or the other, doesn't matter. So we now need to do P plus Q. So that is minus 5, 3 plus 4 minus 5. So when we're adding the vectors, all we do is we add the top two numbers together and then we add the bottom two numbers together. So we add the two x values and then the two y values. So we've got minus 5 plus 4, which is minus 1. And we've got 3 add minus 5, so that's just 3 take away 5. So we have minus 2. And that's our second mark, and that's our answer. So we're looking at question 6. We have to find the volume of the Earth, assuming it's pretty much a sphere. So we have our formula, which is the volume is 4/3 pi r cubed. We get that formula from the front of the past paper. It's given to you in the exam, so you don't need to remember that one. So we substitute in, and we get 4/3 times pi times 6,400 cubed. So that goes into our calculator and we get 1.098, and then there's lots of decimals after that, times 10 to the 12. So we need to round this to two significant figures because that's what's asked for in the question. So the significant figures, we want two significant figures, so it's going to be the first number before the decimal point, so it's definitely going to, the 1's going to be there. But then we've got to see what happens with this bit here. So the 9, just like rounding, means that the 0 goes up by 1. So we get 1.1 times 10 to the 12. And because it's volume, it's going to be kilometres cubed. And the marks for this part are for substituting into your formula, for evaluating it, and then for having it correctly to two significant figures. So if you forget to do it to two significant figures, you lose one of the marks. So we've got part B. So we need to find how many times bigger the Earth is than the Moon. So we have to divide, but it's figuring out which way we need to divide. So because the Earth is bigger than the Moon, the Earth is what we have to go on the top, and we have to divide it by the size of the Moon. And when we put that into our calculators, we get 50. So that means that the Earth has a volume that's 50 times larger than the Moon's. So your first mark was for knowing to divide and for getting them the right way around, and your final answer gets you your second mark. Right, question 7, we've got two fractions and we have to divide them. They're algebraic fractions, which makes it a little bit more complicated, but not hugely so. So, when we're dividing fractions, we should all know that we flip the second fraction. So the second fraction goes the other way around, and then we multiply. When we're multiplying fractions, it's just like we multiply the bottom two together and we multiply the top two together. So on the top we multiply the numbers, we get 10, and then the t and the s squared, can't put them together or anything, so it's just going to be ts squared. And then on the bottom we have st. So now everything on the top and everything in the bottom are all multiplied, so we can start to cancel out. So on the top we've got a t, on the bottom we have a t, so we can cancel them out. On the top, s squared is just s times s, so we've got two s's on the top, one on the bottom, so we can cancel one of each of them out, so the squared goes away, and we're just left with 10s as our answer. So the marks are for knowing to switch and multiply, for showing some kind of form of cancelling, and then for getting 10s as your answer. Okay, so we have a percentage question, question 8. We've got that James paid £297.50 for his laptop. The discount in the sale was 15%, so we have to calculate the original price. So we've got the laptop represented as a bar, that's the 100%, so the whole thing. And in the sale, they took off 15% of the price. So what we've got left to make up that 100% is 85%. So he paid 85% of what we started with, so that's what we've got to do. So we've got that 85% is equal to that £297.50. So we've now got to find the 100%, so we are going to have to get 1% first. So we divide this side by 85, so we have to divide this side by 85, which gives us the answer of £3.50. So 1% is £3.50. We then have to go from 1% to 100%. We've times by 100 on this side, so we have to times by 100 on this side, which gets us that the original cost was £350. So here, your marks are for getting the 85% equals the £297.50, for finding 1%, and then for your answer. Okay, so for question 9, we've got two triangles kind of inside each other. We've been told that the triangles are mathematically similar. So this is similar shapes. So one of the things I would do for this question is, first of all, draw out the triangles separately to make you, because it can be quite hard to visualize what you're doing without drawing them out separately. So you know that this is the smaller one, that's 24 centimeters. Your bigger one, that's 30 centimeters. And this one is PSR. and the smaller one is QTR. So, we know also from the question that the area of QTR, so the smaller one, is 400 centimetres squared, and we've got to find the area of the big triangle, and then we've actually been asked not to find the area of the big triangle but the area of this bit in here. So this kind of section, the quadrilateral in here. So we've got to find the area of this one first, and then we're going to have to take this one away and we get left with what we've got here. So first we need to find our linear scale factor. So because we're going from trying to find something on the bigger one, our scale factor is going to have to be greater than 1 for us to get a bigger answer. So we've got to have the big number and we divide that by the small one. So our linear scale factor is 30 over 24. But we've got to find an area, so we've got our area scale factor. So area, our volume, way I like to think of this is that our area is centimetres squared, so we have to square our linear scale factor. So it's that little link between the square in the units to the square of the scale factor. So to find the area of the larger triangle, so the area of SPR, that's going to be that scale factor squared times the area of the smaller triangle, which is the 400 centimetres squared. So we put it into our calculators and we get that it is 625 centimetres squared. But we've not been asked to find that area, we've been asked to find the area of PQTS. So that's going to be the area of the big one, so the SPR. Take away the area of the small triangle, so QRT, which is the 625. We're taking away that 400 just to get left with that little quadrilateral shape there. So we get that it's 225 centimetres squared. So your marks here are for your linear scale factor, for knowing that you've got to square it and then times it by the area of the smaller one, for getting the area of that triangle SPR, and then finally for knowing to subtract and getting the area of the quadrilateral. Okay, we have question 10, which is an arcs and sectors question. So we've been given the angle and we've been given the length of the arc, and we've been asked to calculate the length of the pendulum. So we know to find the length of the arc, it's going to be x over 360 times by the circumference, which is pi times d. So we have to find d, we know what the length of the arc is, and we know what x is, so we can substitute those in. So we get 28.4 is equal to 65 divided by 360 times by pi times by the diameter. So if we think about this, we can kind of rearrange it a little bit. These things here, we can kind of put it in brackets because they're all multiplied together. So we can take this 65 over 360 times by pi, because they're just both numbers. If we put them into our calculator, we just get a number. So we can take that and we can divide it over to the other side to get the diameter on its own because they're multiplied. So we can get that the diameter is equal to 28.4 divided by 65 over 360 times by pi. We can put it into our calculators, that looks like that, and we get 50.1 once we've rounded it. So 50.1 centimetres. Then that's to 1 decimal place. Okay? And then we have here, what we've got is this length here, AO, which is what we've been asked to find because that's the length of the pendulum. That is in fact not the diameter, is it, that we found, but it is the radius. And we know that the diameter is equal to 2 times the radius. We know the radius is equal to AO. So AO is equal to a half of the diameter because it's divided by 2. So we get 25.05 centimetres for the length of the pendulum. And our marks for this question go for knowing the 65 over 360, one for substituting in, one for knowing how to solve it, so knowing to rearrange, and then one for your final answer, so the length of the pendulum. Okay, so question 11, we've got a table that is a regular hexagon. So that regular, the fact that it says it's regular is really important, because that means that all these lengths, all the sides, are the same length. So that tells us something really important about this hexagon. And we know that the dotted lines are 40 centimetres, so that means that because it's regular as a hexagon, that each of them is in fact 20. Okay, so we've got triangles, we've got the lengths, we need to find the area of the whole table. So the table, you can even see it, they've split it up into 6 triangles. Each of these triangles is isosceles, as we can see, because it's 20 and 20. And we've got our formula that's in our formula sheet, which is a half AB sine C, gives us the area of the triangle. So we need to find out the size of this angle in here. Because it's a regular hexagon, that means that all these angles are in fact the same size. So to find them, we can take 360, because that's the whole circle around that point in the middle, divide it by 6, because there are 6 angles. So we get that each angle, so that angle in there is in fact 60 degrees. So now we can put in our values into here. So we've got the angle and we've got the 2 sides. We have the A and the B. We've got the sine C, so we've got a half times 20 times by 20 times by the sine of 60. So then you put that into your calculators and you get 173.21 if you round it to 2 decimal places, and that's going to be centimetres squared. So that's the area of just one of those triangles, but we've got 6. So the area of the hexagon is 6 times 173.21, because we've got the 6 triangles, so we've got 6 times 173.21, which gives us 1039.26 centimetres squared. And that's our answer. And our marks here come for getting the angle at the middle, so the 60 degrees, substituting it into the correct formula, knowing that you've got to times it by 6, and getting your answer. Okay, question 12, we've got a circle, we've got a little bit kind of out the top, we've been told that it's a milk tank, and we've been asked to find the depth of milk in the tank, so we need to find that height there. A way to kind of look at it is we're trying to find the distance from here, down at the bottom, right up to the top. So we've got 2 different distances. We've got this little bit here, which is the same as the radius, so that's the 1.2. So we can kind of draw this on our diagram. We've got that bit, which is 1.2 meters. And then we've got to find out that other height. And if we think about it, we can make this into, in fact, a triangle. So we've got a triangle here, and these are both radius too, so those are both 1.2. And you've got this here, so we've got this triangle there. We've been told that the width of the surface of the milk, so this bit here, is 1.8 meters. So if we take that out, kind of separate and draw it out, we've got a triangle like this, and in here we've got right angles, we know that. We've got 1.2, we have 1.2, and we can kind of split it up because it's 2 identical rectangles because they're the same, so it's isosceles. So we can make that this bit is 0.9 and this bit is 0.9, and what we need to find out is that height in there. So we've got a triangle, we know 2 sides, we've got to find the third, so it's going to be Pythagoras. So Pythagoras has that c squared is equal to a squared plus b squared. So that's to try and find the hypotenuse. We've got the hypotenuse, so we need to rearrange this. So we're going to have that a squared is equal to c squared minus b squared, where b, that's our 0.9, our short side, and c is always the hypotenuse, so that's our 1.2. And our a is x. So we're going to have x squared is equal to 1.2 squared take away 0.9 squared, which is 0.63. And then we find x by taking the square root of that, which gives us 0.79 meters. And that's to 2 decimal places. Right, so we need to find the whole depth of the milk. So the depth is in fact that 1.2 that we've got here. And then we've got to add on to it this little bit here that we found, that x. So that's 0.79. So it's 1.2 plus 0.79. So we get that it is 1.99 meters. That's our answer. So for this, our marks come for knowing that it is a right angled triangle. Like, so finding this triangle kind of here gets you 1 mark. For knowing to use Pythagoras gets you 1. Getting your answer for x gets you your 3rd mark. And then your last mark is for adding the two together and getting the 1.99. Okay, so question number 13. So we're getting into the hard ones. We've got a triangle here. It's not right angled. We've not got enough kind of information quite yet to know what we're doing with it, but we can kind of gather that it'd probably be the sine rule or the cosine rule. So we've got our information. So on our diagram from here, we've got that Portly is 25 kilometers due south. That's on our diagram. We've got from Portly, the bearing of Rushton is 72 degrees. So that's from Portly to Rushton. That angle is 72. And then the last thing that's not on the diagram is from Queenstown, the bearing of Rushton is 128 degrees. So that's from Queenstown north round to there is, in fact, 128 degrees. Okay, so we've got our triangle. Draw it out at the side. What we're trying to find, we've got the 72 in here. We've got the 25 there. We're trying to find from Portly to Rushton, so this is our side that we want to find, this one. So we need a little bit more information before we can actually solve the question. So we've got here this kind of line here, it's a 180 straight line, so we can find this angle that we've got in here. So it's going to be 180 take away that 128, which gives us an answer of 52 degrees. So we know that in there, that's 52 degrees. So we can take that into here. The side we're trying to find is the one opposite the 52. So that's fine, but the one we've got is the 25, so we need to know what this angle in here is. So we add together the 52 and the 72. So we've got the 52 and the 72. Add them together, we get 124. And then to find this angle in here, we use the fact that we know that angles in a triangle add up to 180. So we take that 124 away from the 180, which gives us that that is 56. So we've got all 3 angles and we've got one side, we need to find another one. So the rule that we use that's one angle, one side, another angle and another side is the sine rule. So if you just write that down, we've got sine A over sine A equals B over sine B equals C over sine C. Again, this is given in the front of the exam paper, so you don't need to remember it. You just need to remember that you've got to use the sine rule, not what the sine rule is. So we've got our triangle, but we've not got any actual letters, so let's label them. So I'll start at the top, call that one A, go B, and go C. And it's the ones opposite it that are the same. So across from the A is little a, across from the B is little b, across from the C is little c. We don't need the little c, so that one can go away. So we have A over sine A is equal to B over sine B. So A is what we need to find, so we just leave that as it is. We've got sine A, so it's going to be the sine of 52 equals B, which is 25, over the sine of 56. So to find A, we have to times by sine of 52 to get rid of that because it's on the bottom of the fraction, so we multiply. So we have sine 52 times by 25 over the sine of 56. Put it into our calculators and we get that that side there is 23.8 and it's going to be kilometres. Okay, the marks for this one go for getting the angle, the first angle, so the 52. You get the second one for putting in your values into the sine row. Your third mark is for knowing how to rearrange it to solve it. And your last mark is for your answer. Right, last question, we've got question 14. So part A, part 1, so we have A1 is, we have to write down an expression for the length of the card in terms of x. So the length is the long side, so we've got this length here. So if we look, we've got the 13 that we know we're going to have, so we can write that down. So we've got the length is going to be equal to, we know we've got that 13. And then what else are we going to have? So we've got at the bottom, got that little x there. So we've got plus x. And then at the top, we have another bit here. It's not, doesn't tell us, but here, this line says the border is x centimetres wide on all sides of the picture. So that means that that is x too. So we can put another x. So we get that it is 13 plus 2x. Okay, so part 2. We need to show that 4x squared plus 44x minus 153 is equal to 0. So we have to use the clues that we've got in the question to figure out how we're going to do that. So we've been told that the area of the card is 270 square centimetres. So we know that the area is 270. We also, in part 1, we found the length. And we know, because this is a rectangle, that the area is going to be the length times the breadth. So we've got the area is the length times the breadth. So we've got our length, but what is our breadth going to be? So that is this from one side to the other. So we've got 9, and then we've got an x on this side and an x on this side. So that is going to be 9 plus 2x, or 2x plus 9. So we've got from the first part, our length is equal to 2x plus 13. It's the same, I've just written it around the other way. And our breadth is the 2x plus 9. So we can multiply these two together. So our area is going to be 2x plus 13 times by 2x plus 9. So now we multiply our brackets. So we get 4x squared. We're going to get plus 18x. We're going to add 26x. And then we're going to add 13 times 9, which is 117. And then we can rearrange, collect our like terms, so we get 4x squared plus 44x plus 117. So we've done that, and we've got something that, we've got some of the bits we need. So we've got our 4x squared, we've got our 44x, we've not quite got 153. So we've got one term for our area here and another one there, so we can set them equal to each other. And if we set them equal to each other, we get 270 is equal to 4x squared plus 44x plus 117. And we've got to set it equal to 0, so we have to take 270 from both sides, which gives us 0 is equal to 4x squared plus that 44x, and then you're going to end up with the minus 153 that we have in the question. So we've proven it. That's us done for part 2. So quickly, the marks for this part. You get 1 mark for the first part, it's only worth 1 mark. The second question, so part 2, you get 1 mark for multiplying it out correctly and knowing what to do, and the second mark for showing that you've got it right. So those 2 lines of working, these 2 lines together, give you that second mark. Now on to part B. So part B, we have to use that, and it says to give your answer correct to 1 decimal place. And what we've got here is a quadratic. So what we're going to have to use is the quadratic formula, because it's told us that it's correct to 1 decimal place. So if we were going to factorise, we wouldn't need decimal places, it wouldn't mention it. But because it's said to do 1 decimal place, that's that little thing in our head, light bulb, that goes off saying that's got to be the quadratic formula. So we need to find our a value, our b value, and our c value. So our a we take down, it's 4, our b is 44, and our c is negative 153. So our formula, we have that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we substitute our values in, we get negative 44 plus or minus the square root of 44 squared, take away 4 times negative 153, and that's all over 2 times a, which is 8. We then evaluate what's under the bracket, so we still have our minus 44. We've got our plus or our minus, and if we put that all into our calculator exactly as it is, you should get 4384 over 8. And this is where we split it up and we get our two values. So our first one, we have x is equal to minus 44 plus the square root of 4384 all over 8. We also get x is equal to minus 44 minus the square root of 4384. Again, divided by 8. We put that into our calculators. The first one, we get 2.7764, and then it keeps going. But we've been asked to 1 decimal place, so that's going to be 2.8. And then we've got our second value, which gives us negative 13.77, and then that keeps going as well. We've only got to do it to 1 decimal place, so it's negative 13.8. So x is equal to 2.8, or x is equal to negative 13.8. Okay, so quickly just going through the marks for that, you get 1 mark for substituting in your values into the quadratic formula, 1 for evaluating the discriminant, so the bit under the bracket. You get 1 for your values before you round, and then you get your last point for the values after you round. So that's us done with the National 5 Paper 2 from 2015. If you've got any questions, don't hesitate to ask them in a comment. Hope this has been helpful for you. Let me know. Leave a comment. Thanks for watching.